I'm absolutely delighted that we have Debbie Roberts here with us today. Debbie is an expert in all things to do with learning, really, but inquiry-based learning is something that I know she's absolutely passionate about. A couple of her books, Mission Science, written specifically for Jamaica, and Discover Science, which is for years 7, 8 and 9, all focus on inquiry-based learning. So I know you're in for a real treat today as she shares her expertise, hints and tips and thoughts on how to help you deliver this absolutely to the best in the classroom. Do use the chat, please. If you can hear us now, just say hello. We like to know that there are people out there and that you can hear us. Use the chat as we go through, put up any questions, and Debbie will keep an eye on the chat box and answer any of your questions. Bit worried that nobody's put anything in the chat box to say they can hear us. Oh, I can see someone is typing that. Excellent, excellent. And a certificate. Hi there. Thank you very much. A certificate with your name on will be coming out to you. It won't come automatically. We'll try and get them out to you tomorrow, along with the recording of today's session, plus the slides, so you can share them with your colleagues. Okay, without further ado, I'm going to hand over to you, Debbie. Thank you very much. Thanks, everyone.
Hello, everyone. So, as Amanda said, I really value your input. It's the sharing of good practice that makes these events what they are. We have got a lot of expertise. So the chat box becomes as if we were face to face in a training room together. So any questions, any queries, any comments, please use the chat box. And if we lose connection or anything, you can't hear, you want to move back on a slide or something like that, then please use the chat box. This is all about you. So that's the best way forward, because we can share good practice that way. So let's move along and look at this enhancing inquiry-based learning in the primary classroom. So some of you might know this as EBTL, Enquiry-based Teaching and Learning. Science inquiry, inquiry-based, it's all the same thing, but it goes under lots of different headings and titles. We'll unpick it a little bit. I will be using some examples from Mission Science. 1, because I'm proud of them. 2, because I need some examples. And so, we'll focus on them. Why not? But it doesn't mean to say that you have to use those resources to teach in an inquiry-based classroom. That's not the case. It's the way that you use the resources that you've got. So hello, everyone. Thank you for saying hello and welcome to our session. So the objectives for today are really about building confidence, becoming more confident at planning, resourcing and delivering inquiry-based learning. This is directed at the primary classroom, but I use these techniques and strategies for every single person that I train or teach. So, sometimes I'll be training really nursery school, reception school children, and then another day I could be in university delivering a session to adults and trainee teachers or skill teachers. So these strategies work for everyone. And you could have a 4-year-old who's incredibly talented and skilled in inquiry-based strategies, and then you could have a 50-year-old who knows nothing about it. So it's not even age related. It's about training and becoming skilled. Alongside this, I'm really interested also in STEM activities. Science, technology, engineering and mathematics. Sometimes you might see that as STEAM, and I'm sure you're all shouting out at me that, yeah, you've missed the arts out. Well, yeah, we have, but most of them are included anyway. It's all a big package. The reason that we're so interested in STEM now and training our children in STEM, it has become a real big buzzword over the last few years. I've worked with a lot of people consulting and advising in STEM activities. In fact, I'm working at the STEM Centre at one of the universities, running residential courses next week and over the summer. So it has become increasingly popular. Why? I think it's because of the pandemic. We all had to become better. We all had to use technology much more efficiently. I think also STEM activities they cover everything. So we find ourselves being able to teach lots of curriculum in one lesson even. And so that's important. And also, I say this in all my sessions. If any of you have been to my sessions before, you'll recall that I always say technology is moving at a rapid pace, much more rapid than it's ever moved before. And our children will become students, will become employees in a world that we can only dream about. Technology is progressing so fast, we don't know what they will need in their workplace, but we do know that they'll need skills. And so that's become a focus for us. So we're also linking all that to scientific procedure, methodology as well. And as I said, I'll be using some of the examples from mission science because I'm proud of mission science. And when I first started working in this field some years ago, I was very fortunate to actually work with some teachers before we actually started to develop the resources for them. These resources became very popular, and I always believe it's because we wrote them for the teachers that would use them, and we wrote them with the children in mind that we'd met. When we adapted the Jamaica Science for you, it's very passionate for me because I'd actually been out to Jamaica. I'd spoken to parents, children's teachers. I'd spoken to people from bookshops, things like that, and I got a real good sense of how special and how specific the learning is in Jamaica. And so I love to see the flag on the front of the book. For me, that flag there on that rocket says, "This is for you." It's written for you, and we listened to what you wanted and we tried to address that. So I'm really proud of them. So what is inquiry-based learning? Why are we even bothered? Well, it's skills-based. That's the main thing. It encourages skills. You can't even engage with an inquiry-based lesson without developing skills. And I always call it training, because when we first start, we don't understand the principle. Lots of teachers go, "Oh no, I can't do that. No. I need to, control this class. Behaviour management, health and safety. I need to control it. I need to master it. I need to be in charge." And it's really daunting for teachers, and it's daunting for students. All of a sudden, they're being told, "Yes, you can. If that's what you're interested in, you have a look. You go for it." So inquiry-based learning supports so many different skills. It supports resilience, problem solving. It supports communication, working in a team, working in a group, working independently, research. And again, that's a massive big area. We all know that in the future we'll still use our research skills. It supports things like methodology. We can think about how to work methodological, you know what I mean? We can work to a method, to a precise method, to specific steps, and we can think about what we expect the outcome to be. But when the outcome doesn't actually arrive, or it's slightly different, it's not wrong. We don't say it went wrong, we say it's not quite as we expected it to be. And we have the confidence to actually be able to think, okay, that's not what I expected. I'll just do it again. And so that they are the fundamentals of inquiry-based learning. Students take responsibility for their learning, they're taught reflection, they're taught how to time manage, how to manage their resources. It's a massive range of skills that can be taught. So, for example, this is a picture from one of the mission science books for Jamaica. So we've got some wind turbines there. So I like to use pictures a lot, and you'll see if you've ever used those resources, there are lots of pictures. And the reason for that is that they stimulate thinking. act as an invitation into the learning. And what we hope is that the children will begin to ask questions about what they see in front of them. So it helps us to guide the students to where we want them to be, but we don't actually stand at the front and tell them. We're guiding them along. And so with this picture, what inquiry-based work could we promote using that picture? Well, there are a whole host of things. Early in sort of year 7, you know, when students, middle to end of primary, we have students that think that measuring is boring. And why do I have to measure in centimetres? Why do I have to measure in kilograms? What is a kilogram? It's boring. When am I going to use this? Well, we can say to the students, okay, so measure that wind turbine then. What equipment might you need? Oh, well, will a ruler work? No. Will a trundle wheel work? No. Will a meter stick work? No. And so already they're starting to think about the problem solving. Yeah, how can I measure that? Is that a maths task? On the surface of it, it is. But maths is a science in my view. Maths and science go together. Maths makes sense of what we observe in science. Technology helps us to work out what we do in science. Engineering helps us to put together the ideas that we have in science in our hypotheses. And so really STEM is everything. So this activity is a STEM activity. So it's nothing special, it's nothing expensive. So measure the room you are in, but you're not allowed to use any equipment, no specialised scientific measuring equipment or mathematical measuring equipment. All you can use is your hand. So what method would you use? Would you prefer to work in a team or a group? Would you rather work independently? How long will it take you to measure this room, just you, with no support from anyone else, using your hand? Quite a while. Suddenly we start to recognise the benefit of actually working in a team because we can share the workload. We can share the workload and we can also share expertise and knowledge. We can bounce ideas around. We can make life much more, well, effective, easier. We can make our time management better. So this activity actually teaches lots of different skills and lots of different ideas and enforces inquiry-based learning. So why do we have kilometres? Why do we have kilograms? What is a kilometre? What is a kilogram? Why are these standard measurements? Why? Well, we can tell stories about way back in history. We know that people bought fabric by the length of the arm. Now, if you compare lengths of arms between different people, you'll see that they vary immensely. And so it became that if you go down the road, his arms are actually much, much longer. So if you buy 2 arms, you actually get a lot more for your money. And so we had to standardise. That makes sense to some students. Right, I get it now. That's why we all use the same. How do we know a kilogram's a kilogram? You know, we sometimes have wise students in our classes. One student once asked me that. Yeah, but what is a kilogram? I could say it's a kilogram and it could actually be 2 kilograms to you. Who knows what a kilogram is? Well, we know what a kilogram is because we have the standard kilogram, which is kept in a vacuumed glass container. And that is what we measure not every kilogram, but we often standardize the measurement of the kilogram to that. And it is kept it's kept in Paris in France, but we can access that, and that is the standard kilogram. So we can always back up what we say with science. So planning. Okay, in the inquiry-based classroom, you know you've arrived if you spend very little time teaching. Ooh, shock horror. So I remember when I thought, that's it, yeah, I've my class are inquiry-based practitioners, I've done it. And it was always a very noisy classroom, my classroom, because I encouraged group work, collaboration. Students knew not to come and ask me a question unless they'd asked every single person in the classroom the question first. And the very, very last resort was, Miss, you need to stop because nobody knows the answer to this question. So then we'd stop and have a debrief. Okay, why don't you know the answer to this question? So you can imagine lots of movement, lots of activity, lots of noise. So before someone types in the chat box, we haven't got those facilities in our classroom. No, you might not have at the moment, but why can't you change it? And if you really, really, really can't change it, then adapt those ideas. But ideally, we want students to know that they can communicate with each other and collaborate to problem solve. Okay, but when you start out, it's not so much like that. So in one of my classrooms one day, over the noise, I don't know, but you can always hear the head teachers, you can filter it out, the head teacher's voice. And I remember the head teacher saying, so where is Miss Roberts? And the student went, I don't know, I haven't seen her for ages. And I thought, yes, they've not even noticed that I'm still there because they don't need me. And you're thinking, what? They don't need the teacher? No, they didn't need me in that lesson because they had trained to be inquiry-based practitioners and the lesson was designed for that class, for inquiry-based learning. And so, no, I was able to move around, sit with the students. I've got pictures of me sat on the floor with them, with rolls of paper, problem solving. I was able to sit with groups of children and really listen. The best assessment in the world, I was able to differentiate hands-on because the lessons were very cleverly planned. Sorry, I was just reading. Hi, glad you can all, it seems like everyone can still hear quite well, so that's good. Thank you for that feedback. Okay, but when we're planning, what skills are we actually planning to encourage? We can't encourage all of them. We need to focus on one or two. Do they actually need any prior knowledge? We're not just going to throw an investigation at students because it's fun. What do they actually need to know? What foundation do they need to know so that they can build an activity on that? What resources do you need? And that includes people. Sometimes it might be that you need more people around. Do you need to use a specific piece of equipment? Is that piece of equipment being used elsewhere in school? I don't know about you, but the schools I've always worked in, we've had a tiny, tiny budget. And so we might only have 5 trundle wheels in the whole school. And so it would be silly to plan a lesson when I know that they're using them in maths or something like that. So we need to think carefully about the resources. Do I need to start collecting something? Do I need clean jam jars? Do I need cardboard tubes? Do I need to start collecting things for that lesson? How will they actually show me? What's the outcome? What am I looking for? How are they going to show me that they've engaged in this activity? Will it be a table of results, a presentation, a drawing, a graph? Think about that, and that's where the time comes in the planning stages. This is taken from the Mission Science books. So why do you need to plan it? It's all planned there for you. I'll come back to that in a minute. So why should we? What's the point? Now, not only does inquiry-based learning actually develop a much higher order of information, of a much deeper intellectual level of thinking. Information literacy is a much higher level. Critical thinking skills come naturally. They're able to problem solve and they develop lifelong skills. So when we look at those pictures there, is that just in science? Is that going to be one of the scenarios where the children say, why do I have to learn this? I don't want to be a scientist. Would they protect you anywhere else? Would they keep you safe? Do they keep you safe in Jamaica? Do they keep you safe in, I don't know, India? Does it matter that we speak different languages? No, these are safety symbols that they will find on everyday products, on cleaning products, on some personal hygiene products. There they are, on the door into a cupboard at school or in their place of work. It might say, do you know what, there's electricity in here. So it develops lifelong skills. The children you're teaching now, it doesn't matter what age they are. The children you're teaching, you are skilling them for life. They will use those skills for the rest of their life. My son recently bought a house and he said, I actually use problem solving. I weighed up, I analysed the data. Would it be better for me to pay that much deposit and then pay this? Do I pay that much per month over this many years? He weighed it up. He actually was very critical about the information that was in front of him, but he had the confidence to actually weigh it up and to actually form a decision based on evidence. And so he's used those skills even at 30. So what's STEM? So, okay, communication, collaboration, fair testing, standard units, these all come into it. We can't really say, well, we only used research in engineering actually. Well, we only use standard units in maths. Or reliability, that's only about science. No, that's wrong. All those are linked to STEM, and STEM covers everything. The reason for it being so important is not only because we need to tick that STEM box, but it's about life. It's the life around them. It's the real world around them. For me, science comes up with ideas about the world around them. We use maths to test these ideas and to come up with evidence. We then use technology to design, to plan, to think about how that would work and how we can make it cost effective. We use engineering to actually put into the world the ideas that the scientists have. So they're hand in hand, they work together, and the rate that technology is progressing at the moment, it's essential that our students are confident, competent STEM people. It's as simple as that, in a nutshell. Now, if we were together, I make no excuses for using information that I pick up from teachers, and I think that's why we develop some really good resources along with Macmillan, because I do listen. I listen to what teachers say. So every time I run a course like this, and way back when we'd be face to face, I always say, what skills do you think we should develop with our children? Doesn't matter what age group you training, teaching, doesn't matter. What skills do you think? And I get people to write down all the skills. And then what I do is I steal the most common written skills. And this is based on the last course I ran a couple of weeks ago. And these are the most recent ideas. There are far too many words on that slide as it is. If I added all of the skills that can be developed, it would go over slide after slide after slide. There are lots and lots and lots of skills, but these are the most common ones at the moment, and they change slightly. So at the moment, we've got lots of things about recording, working collaboratively, sorting, classifying, ordering, lots of hands-on things that maybe a lot of students might have missed when we were homeschooling and things like that. So it's slightly different now than it was a couple of years ago. It's funny because a couple of years ago, research, technology, using technology was quite high up on the list, and that's dropped now. I wonder why that could be. So there's another one. There's blended learning for you. So that's come off the list now, which is really interesting. Also, we now know that the evidence back in about, I think it was towards the end of 2019, just 2021, worldwide, 60% of children had access to the internet. Wow. That's in just 3 months ago. The recent predictions are that that's raised to 68% worldwide. Now, that's a big leap. 8% in 3 months is a very, very, very big leap, because in the 2 years before that, we were talking round about, I think, late 50s, something like that percentage. So it's moving. You can see that it's moving at a progressive rate. So a few years ago, less than 50% of children had access to the internet. Now we think we're approaching 70%. So therefore, research using technology has dropped off this list because children actually are very skilled at it. My godson picks my smartphone up and shows me things that I did not know could be done on the smartphone, but he just does it instantaneously because they're very confident. Okay, this is an idea about inquiry-based skills, and this is taken again from the book. So you can see there's a trophy there just by the side of number 4. That is a challenge. And sometimes teachers have said to me, yeah, but we don't need to know that. We don't need to know that on the curriculum. But we're not teaching to the curriculum all of the time. That's not our main focus. We have to cover the curriculum in order to prepare our children for assessments. Whether we like assessments or not, that's how we assess progress at the moment. And so we have no choice. We have no choice but to assess our children. And so we do teach to test, because we have to, because otherwise our children won't progress further. And it's as simple as that. But that doesn't mean to say that's the whole story. We needed to synthesize knowledge. Remember Bloom's? Synthesizing knowledge is right at the top. That's the deep intellectual thinking, the deeper intellectual understanding. And so on these pages, you will find challenged questions that just stretch a little bit further, that just get the students thinking a little bit harder. Underneath there, you've got a research task. So this is asking students to research an example of a suspension, a colloid, a solution. Don't necessarily need to know that, but it is interesting. It's like when I'm teaching states of matter. I hear teachers say the 3 states of matter. Well, there aren't 3 states of matter. There are more states of matter. Why do we tell them there are 3 states of matter and then build on that later? Which one are they most interested in? Sublimation. In my view, that's the one that they all go, wow, I thought that was smoke. No, it's not. It's not smoke. It's carbon dioxide. And sublimation, it just misses out that middle layer. It isn't a liquid. And so it becomes interesting and engaging. Are we wasting our time? No, we're not. Because if they're interested and engaged, they're learning. Asking questions is at the heart of inquiry-based learning. It absolutely is. Now, these next 2 slides cause more questions and comments than anything else. So bear with me. Sublimation piques their interest. So you agree with me there? Yeah, it does. It always has done for me. But I think probably because it always piqued my interest as well. It fascinated me why you could have a fire in a I don't know, somewhere where there was a public space and there's a play going on with lots of people and there's a fire in the room. No, there's not a fire in the room. It's sublimation. Yeah, ask my students, what is dry ice? What's it made of? That's really interesting. I would imagine, I'd love to hear the answers to that actually. Please ask your students that and send in the answers. That's really interesting. It's a long time since I've asked that question, but it is interesting. And yeah, if then they're interested in evaporation, condensation, then why not throw sublimation in there if it piques their interest? So, questions is at the heart of inquiry-based learning. Now, if the students come up with the question, why do I say that's powerful? That is powerful, because if we ask a question, what are we? We're interested. And once we're interested and we've piqued our interest, suddenly we want to know. And if we want to know, we are driving our learning. And so we absorb much, much more. And guess what? Remember it. Recall is better. So It's important that students ask questions. It's very important that students ask questions. But why do we ask questions? What's the point of it? How effectively do we use our questioning in the classroom to actually promote the deeper level of understanding, that deeper thinking? These talking point questions I've put in there because this is not an assessment point. We don't really want the children to put their hand up and answer the question. What we want is discussion, because discussions are also very important in inquiry-based learning. Why? Because students are more confident when they're talking to their friends. And so they might verbalise words and comments that they wouldn't normally. Standing up in front of a whole class, putting the hand up is quite daunting to a lot of people, especially if you're not 100% sure. So these discussion points are to encourage children to talk to one another, to problem solve, to figure it out together, because they tend to know a lot more than they think they know. And the research tells us they learn more from each other than they do us. So there you are. If we were doing a residential course now, I would say your homework for tonight is to go away and find a picture, doing a search online of a classroom, and see if you can find one where the teacher is not directing the learning. And you know what? You probably won't, because inquiry-based learning is not that well known. And so most teachers stand at the front conducting their class. Do all of the children in that class look engaged, focused, interested? I'll leave that one with you. The teacher stood on her feet all day at the front of that class. She must be exhausted by the end of it. Why? Because she's asking questions. So how many questions do we ask in a day? Well, we're not in a room together, but I would be saying write that down on a post-it note, and the range is huge. Some people say less than 10. Some people say hundreds. And it is actually hundreds. So Stephen Hastings did some research in 2016. It's been repeated again at the moment, I believe, and the results are even more startling than they were then, but they've not been published yet. So these are the last published ones. Stephen Hastings went around classrooms with his clicker. Every time a question was asked, he clicked. He followed a teacher around for a teaching day, whatever that was in that school, and he went into hundreds of different schools, cross the range, cross age range, and he clicked away, and the average was 400 questions a day. When the percentage is calculated, it's an average of 30%, almost a third of teaching time goes into the teaching asking questions. So my question then became, when I went into schools, how many of you plan your questions? When you're doing your planning and you've got your planner or your piece of paper or your, I don't know, back of an envelope, whatever it is that you use to plan, how many questions do you write down? And if you were in front of me now, I would not be surprised if you said none. I don't write any questions down. Why would I write questions down when I'm an experienced teacher? Questions come automatically, and they do. But are they the right questions? Do you ever ask yourself, why am I asking that question? What am I actually looking for? What's the right answer? What will I do if they actually don't give me the answer that I'm looking for? What question can I follow up on? Is that actually developing that deeper intellectual level? So why do we ask 400 questions then if we don't even plan them and we don't even know why we're asking them? Why? And the research told us, mostly to get attention. Why are you doing that? Mostly to check their understanding. So if you had 4 apples and 2 oranges, how many pieces of fruit would you have? 6. To reinforce or revise the topic. So what is sublimation? To encourage thinking. So what would happen then if? To develop a discussion. I'm not really sure about that. Why don't you go and ask somebody else and see if they know? Come back to me and let's work it out. The last 2 are the ones that inquiry-based learning we should be planning the questions for. We should be thinking about, okay, so this is the topic, this is why we're doing it, this is what we're doing. How can I actually encourage them to think for themselves, every single person in that classroom? How can I develop a discussion? Well, you can use mission science because it's all done for you. But just as a reminder, Bloom's taxonomy. I'm a researcher, I'm an author. When I see on a Google search or an internet search and it says the new improved Bloom's taxonomy, what does that say to me? Why? What's wrong with Bloom's original research? Nothing. It served us pretty well. Be careful when you look, because some of these new Bloom's taxonomies are actually wrong. Some of the descriptions or the definitions, some of the ideas, some of the recommended vocabulary to be at each different level is not always accurate. So be very careful what you use. But you're experienced people. You can problem solve it for yourself. But I particularly like this one, and that's why I included it. There are flaws to everything we use, but this one's a nice one. In fact, I used to have it on my desk, sellotape to the desk, so that when I was asking questions, I could think about, okay, so you've been working at that level for a while now. We need to actually start to stretch your thinking a little bit further. And so I'd kind of look at that and think, okay, we need to be looking at trends and patterns now. We're not just recording results anymore. We need to be thinking about that and evaluating, is that data actually reliable? Does that actually support my conclusion? So here we are in these lovely books. You have, and remember, you don't have to use these books. It's the way that you use the research, the resource rather. So why not use what you've got? In the books, wherever there's an activity or an investigation, it's like on that graph paper so that the students become very familiar with it. I have written some lower secondary science to follow on, and that was one of the things I was really keen to keep, because I thought if students have been using these at primary level, when they go into secondary, it'd be very comforting to think, oh, there's an activity there, or there's an experiment, or wow, we'll be experimenting soon. And they automatically know that that's going to be an hands-on opportunity. But do they need to do their investigations? All of the investigations in everything I've ever written are not add-on. They're not for the fun of it. I was observing a lesson a few weeks ago, and the children were all given fish, a whole dead fish, on a paper towel. And the idea was they wanted them to inquire, and they wanted them to look at the fish and see how the fish was adapted to its habitat. But the children didn't know about this, because actually the teacher had put this lesson in to impress me as the observer. So when I asked the students what they were doing, they didn't actually know what they were doing, because they'd not had any of the lessons that built the foundation for actually looking at how the fish was adapted. It was a great lesson, but the children were not skilled and they were not prepared. They didn't have the background knowledge. So it was an add-on. It was an absolute standalone add-on that did not enhance the learning that had gone before or support any learning after. Again, stimuli. I am massive on stimulus. I love stimulus. In agenda building lessons, stimulus is the part where the students go, wow. And in fact, I used to call them wow pages. In fact, editors who've worked with me know that I call them wow pages. They are the wow factor. That is not my artwork. I cannot draw. I am a scientist. But look, their pictures are great. There's so much going on. There's a bird, a butterfly, a hummingbird, flowers, plants, different leaves, grasses, food, roots. We've got a fascinating fact in there. To get interest, I'm keen on real world science. We're not just studying this to pass an exam. This is about the world around us. Scientists are working all the time. And when we were putting in the real world scientists, I can tell you a great deal of effort went into finding Jamaican or Caribbean scientists that have worked in fields and made huge differences to the scientific community. And that's important that students know it's not somebody in a white coat in some far off tower. No disrespect to anyone, but usually a grey-haired man. They're not scientists. We're scientists. They're scientists. Anyone studying sciences. And so I also like to bring that out and look at all the talking points. The talking points are everywhere. This is in a workbook, so this is intended for students to write on. Because in investigations, is it necessary that a student follows the whole investigation? And I used to think it was, that they went from planning a methodology, collecting data, measuring, analysing, evaluating, and it was a process, a method, a strict method. But we're teaching here. We're not necessarily training scientists all of the time. We're teaching as well. If your students are incredibly good at recording results, why do we need to let them repeat? Why do we not just let them share in the whole class to see if they've got reliable results? If they're not particularly good at planning, do we spend a whole lesson planning and they don't actually engage with the activity? Lots of people argue with me, but if they don't understand why they're doing it, why would they do it? I've just said that. I'm actually contradicting myself. But this is where inquiry-based learning comes in. If they can't plan and they spend the rest of their lessons trying to plan, but they've never actually carried out a plan, they won't know how to perfect it. If it gets to a point and you think, okay, we're not doing really well with this plan, give them a plan. Model what a good one looks like. Give them a plan. Let them follow the plan step by step and think, oh, right, that actually doesn't work. I needed to measure that first. I needed to measure it at the start. I needed to control the temperature in the classroom. And suddenly the planning becomes better. So we don't always have to do the whole thing from plan to evaluation. We can, in science, do it in chunks. And so we're building on that skill that we need to develop, and then we move on. And then we might have to go back again because the children and the learning, and they have a lot to learn. So the workbooks are great for inquiry-based skills because sometimes why waste time drawing a table of results when we need to be practicing measuring? So give them a table of results. Not only do we allow them to practice measuring, we give them more time, but we model what a good one looks like. I used to sit there thinking, why are we all sat here on a Sunday night planning the same lesson? All around the world, we're all planning the same lesson. Why? Yeah, why? Here we go. This is a teacher guide that we wrote to go with the resources. These are lesson plans, really. They tell you how to set things up. They give you alternative resources. They tell you about answers that they might give you, what to do with them if they don't give you, how to restructure things, what to do if students are not very confident in certain areas, or if students are extremely confident, how to challenge them. Lots of tips, ideas, how to manage your classroom, how to stay safe. It's all there, all done for you, which means you can spend more time in the classroom. If we were together now, I would have set up lots of investigations around the room, all things that are specific for your curriculum. And I would say to you, okay, Move around the room, have a go, evaluate each activity. Think about, can they actually do this independently, or am I being a little bit too positive? Do I need to give them a bit more support? Do I need to take a step out? How much foundation prior knowledge do they need? What support do they need? Are they okay? Is this class okay actually to use boiling water or not? And you go, oh no, they're only primary children. Some are, because they've been trained. How can you differentiate so that all of the learners can actually access this activity? What are the health and safety rules? The H&S. How can I keep them safe, me safe, and the other people in the room safe? Why is it most important that I say, how can I keep me safe first? Because like on a plane, if I go down, we all go down if we're doing a practical. So we keep ourselves safe, we keep our children safe. How can we do that? You've thought about it before. Do I need any resources? Do I need to start collecting cardboard tubes? Do I need lots of egg boxes? Do we need anyone else to come into the classroom to support us so that the children can be more independent? And do we need more time? Does this need to be stretched over 2 lessons, or can I fit it all into one? So this is one of them. So this is investigating storage routes. So do they actually know about the structure of a plant? Do they know what the roots do? Are they familiar with root products, root vegetables like sweet potato, cassava, turnip, carrots? Are they familiar with them? Do they make sense to them? Do they come into contact with them? Is there something else you could use? And there's the investigation. We've got ICT identified and highlighted there because we know its importance. Can they actually just get through that? We think with training that every single activity in all of the books, children are more than capable of engaging with them independently. This one's about the environment. It's really important that children learn about the environment. So there we've got studying a local environment, the actual activity, the actual activity that they'll be involved in around their school, their local area, because they're making sense of their local area, the place where they live, because that's what science is. We've got ICT, we've got an internet research there, so students can work in blended learning, they can learn remotely using these resources. And then we've got a workbook page, somewhere for them to take that out with them on their field trip, to make their recordings, to think about questions, to take them step by step to analysing the data that they collect. Columbular, I love this lesson. I do. And you'll go, well, my children don't need to know about columbular. Yeah, but if you've got a microscope, number one, they learn how to use a microscope. Number two, they learn about the most abundant insect on the entire planet Earth. These are found everywhere. They are known as the free living omnivore because they can adapt to wherever they seem to be. And we find them everywhere in healthy soil. This is a fun activity that I've carried out with loads of children. I have a great fun doing this. If you put your hand in a bag and you slide your fingers into some leaves or dead decaying leaves, grasses, whatever you've got, you tie the top up because they jump. They jump about 1 metre in height, even though they're microscopic. You tie the top up. You make a tugger funnel like in the picture using a clean soda bottle, a bit of netting or some old tights over the end. You put the sample into the upturned tube. You shine a light onto the tube. Columbular are soil invertebrate. They like dark, damp, cool. We put a lamp on, which is light, hot, and dries out the leaf litter. So what does a columbular do? It's very, very, very clever and is adapted to all its surroundings. It burrows further down, and what happens when it gets to the neck of the bottle? He falls through the old pair of tights into the bottom, and all the leaf litter is held back. We turn it out onto white paper and it just looks like black gravel, really. We look at it under the microscope and it's phenomenal. They're called spring tails because they have a tail at the back that flicks them forward. So in one lesson we have chemistry, biology and physics. We can look at the environment and say, why are all the weeds growing there but no weeds are growing there? And you can guarantee if you take a sample from both, there'll be lots of columbella where the weeds are growing and zero columbella or dead columbella or not many where they're not growing. The beauty of these is they have a very hard exterior skeleton, and so they do take quite a while to break down, so you can actually almost measure, but there used to be columbella here, so what's gone wrong? Because you might find a section of its skeleton. So there used to be columbella living here. Why are they no longer? What's changed? Is there some pollution? Usually there is. Usually that's the factor. They're very sensitive. So that's an extension of the soil lessons. The soil lessons, if you get a sample from the same place you've got your leaf litter from, get a soil sample, put it in a jam jar, a clean jar, pour it, fill it about quarter to a half full with clean water, shake it up, leave it on the side. You can see the levels separate. You can look them up on the internet, tells you the different ones, or there are samples in the book. We know that we can grow food better in humus or humus, depending on how you pronounce that. But we know that more plants grow. We have a world food shortage. So it's very important that we know what kind of soil and what kind of environment plants can grow best in. And so this is introducing all these environmental ideas. We can look at materials. Now, I learned very early on in my career. I also learnt very early on as a child that burning things was very interesting and fascinating. So therefore we have to burn things. Obviously you have to make sure that your students are very, very safe, that students who are trained will automatically read the stay safe box first because they know that's important. So that's what you need to point out to them. On this particular investigation, students are measuring the mass of a piece of paper. They burn the piece of paper, they measure it again. Ask them to make predictions. Will the mass increase or will it decrease after burning? Listen to their ideas because it's all about combustion and it helps us to understand any misconceptions that might be developing really, really, really early on. We've got another one just using baking powder, baking soda and juice, orange juice, lemon juice, lime juice, whatever you've got, even vinegar. How much of those two investigations cost? Very little. How much does juice and baking soda cost? How much does burning a piece of paper on a metal tray cost? But make sure you've got a fire extinguisher or something to extinguish the fire, just in case. Can the children do that safely? Depends how your children behave and how well they're trained. But if a class walks past another class and they're burning paper and you're not allowed because you can't behave, suddenly they will change their behaviour. Anyway, behaviour is all about engagement. We should never have to manage behaviour. We should manage engagement. If children are interested, they generally are very well behaved. Describing properties. Give the children lots of different things and ask them to group them. Their initial ideas will be colour. Colour is not a scientific property. Because you could have a pink helicopter or you could have a pink fingernail. They behave very differently and their focus is much different. So colour is not a good scientific way to organise or sort materials. What we need to look at is things like this one says, how could you compare the objects of the properties of the materials if you didn't actually look at them, if you couldn't see them? So we'd be looking at, do they feel shiny, do they feel smooth, rough, fluffy, are they warm, cold, is it does it smell, does it look different, does it, all these different senses that we can use other than colour. And there's lots of different ways we can do that. And again, we've got some differentiation there in the workbook, and that's actually working, looks like, with someone at home, and they're actually being the guesser. What is it? How can you guess? How can I describe it so you can describe it so that you can guess correctly? There's another talking point there, and you are all now very familiar and know that these are not assessment questions. These are discussion points, talking points, not assessment. Again, investigating the changes of the state of water. These are all based on questions that students have asked me in lessons. So, Miss, does ice, does it weigh more than water? Well, so long as you've got the same volume, you can actually investigate that, can't you? So you could just use a small bottle of water, pour a bit out, obviously, before you start the investigation, measure the mass of it, put it in the freezer overnight with the top tightly on, but a nice gap so it can expand, and then measure it again. And why do we know it'll be the same mass? Or do we know it'll be the same mass? That's an interesting one for you to investigate. If you were stuck on a desert island and you needed to make, I don't know, you were cooking, as you do, and you needed to make a recipe that told you that you needed a kilogram of water, or but you haven't got a top pan and balance, you forgot to pack that, you didn't take the weighing scales, so how would you know? Because there's lots of pop bottles that you can find washed up on the beach because of pollution. So how would you know? Because, is this true? Does 1 litre of water, does that measure 1 kilogram? Does a milliliter of water measure 1 gram? Interesting. And these are questions that students have asked me. So when they've asked me, I've said, do you know what? Let's see if we can find out. Remind me. And I've made sure that goes into a lesson, if not straight away. I run training courses for adults and at universities, and I always ask for lots and lots of equipment. And when I first started, the technicians used to say, what are you going to do with all this equipment? Why do you need it all now? And I said, because I will use the equipment when my audience demands it. So if they ask me a question and I look across and I can see the equipment, I don't know, go and find out. We can't always do that in a lesson because we haven't always got the equipment. If we have, you'll notice that it soon becomes powerful. Are we all okay still? Anybody there? Can you still all hear me? It's gone very quiet. So, exploring the water cycle, what are clouds? Yay, thank you everyone. Are you just engaged and engrossed? Thank you for that, that's good, I'm glad. So, what are clouds? Let's find out. Easy way to do it, jam jar, clear plastic container. If you haven't got a lid for it, just put some cling film over the top, or any kind of lid really. Warm water, not boiling water. Quarter to halfway up the jar, ice on the top, water evaporates, condenses very quickly and becomes a cloud. Some of the children will say, I can't see the cloud, miss. Yes, that's because there's no pollution in the jam jar. Often we can see clouds very clearly because of the pollution in the atmosphere, because of the particular mass that's out there. So, like, strike a match, dip it in the top briefly, not in the water, and a cloud will appear. Or spray in a CFC, an aerosol, a deodorant, or what else can, hairspray. That works also. Just a little bit, and you'll see that the pollution, suddenly you can see the cloud, and we can start to talk about weather, rushing along. Can we measure magnetism? Not easily. With a top pan and balance, you can. If you put a magnet, use different magnets near the top pan and balance, you will see that it has a different reading. That's very interesting. Similar with the light one and the calculator. Cover it over with sheets of tissue paper until no more light can get to the calculator. Gives you a good comparison of the amount of light coming from different torches, lamps, candles, that kind of thing. Investigating air pressure. Students tell me that air has no mass. It can't have mass because I can't feel it. Measure the mass of an empty balloon, a deflated one, blow it up, measure it, then tell me air has no mass. Okay, so there they are. They are the books just for you, the Jamaican ones. Thank you so much for listening. Before I disappear, we want to run some more webinars for you. And as I said right back at the beginning, if you can remember, we do like to provide resources for you, things that you want, that you're interested in, your needs. So we hopefully will be delivering some more webinars. Hopefully I'll be seeing you all again soon. So if you've got any ideas or topics or content that you want us to cover, please let us know, and then I can develop something great for you that's just for you, and it's more personal then. Thank you so much for giving up your very, very precious time. I've enjoyed myself. I hope you have. And I'll pass over to Amanda at Macmillan. Thank you so much. And thank you for your comments. I really do appreciate that. Thank you.
Thanks so much, Debbie, delivered with your usual passion and enthusiasm. And yes, I agree, Nadine. It was a great presentation. Thank you so much. Just to let everybody know, you will be getting a certificate with your name on, the ability to watch this again as we load it up onto our YouTube channel. You'll also get the presentation. And if there are any particular areas that you think, I really understand how I can apply inquiry-based learning to this, a particular topic or subject, particularly as you move towards the PEP, then do let us know. Email caribbean@macmillaneducation.com. Thank you, Debbie. I was about to say move on to the last slide. And we will put the event title onto the certificate. Thank you, Frederick. And but do seriously do let us know, because we'd love to put together a sort of a range of webinars that will cover any of the topics that you think, actually, I'd really like a little bit of help with this, or I think my students would like a little bit of help with this. Thanks all very much indeed. Enjoy the rest of your day. Debbie, thank you once again.
Thank you. Thanks,
Goodbye,
everyone.
everyone.
Thanks,
Bye-bye.
Frederick. Bye.
Bye.
Bye.